Welcome. Let's see. We just finished the tutorial on compound angles, which is the sum and difference. So that very development can be used to find what they call double angle identities. So we can see that the identities, okay, so these identities that we have previously under compound angle, the sine of alpha plus beta, the cos of alpha plus beta, and the tan of alpha plus beta can also be used to derive the identities of the double angle identity, which is sine alpha 2 alpha, the cos 2 alpha, the tan 2 alpha. These are the double angle. You can see if you look at 2 alpha, it is the same as alpha plus alpha. That is double, the same angle being added. All right. So if you want to pick this very one, let's start with the sine. We know the sine of alpha plus beta is the same as the sine of alpha, the cos of beta, plus the cos of alpha, plus, okay, I think it's multiplication, the sine of what? Beta. This is the expansion for the sum of this sine. Now, since we are saying double, let's just say we let beta equals to what? Alpha. So that this becomes alpha and alpha. If it is alpha and alpha, then this becomes, this implies that from here, we are still going to have alpha, then the cos become alpha, plus this become the cos of alpha, then the sine of what? Alpha. What can you see? Sine alpha cos alpha, sine alpha cos alpha. So it means that this is the same as this. No multiplication. If I replace all this by y, it will be y plus y. And y plus y is what? 2y. That means that sine of this is also alpha. So alpha plus alpha is 2 alpha equals to 2 of sine alpha cos what? Alpha. This will be the first one, the first identity we are going to have, which is 4, the sine 2 alpha. Are we good on that? Then we can take this by also picking the compound angle for cos. So cos and alpha plus beta expanded to be the cos of alpha, the cos of beta minus the sine of alpha, the sine of what? Beta. But if we take alpha, how do you call it? Beta should be equals to alpha. That means that this still remain cos alpha minus sine alpha, sine alpha. Somebody suggests to me that my board is too small. I need to get a longer one. So if we're to have a bigger board, all this is supposed to be in one straight line to show the subtraction. But I think as we are growing, definitely we might get a longer one. So what do we do? I can see cos alpha multiplying together. So let's just say cos alpha is taken as y. This means y times y. That is y squared. So this simply means that I should be having here being the cos square alpha. If this is k, that's k squared. So I have what? The sine square what? Alpha. So that means that if this is alpha, it becomes the cos of 2 alpha equals to cos square alpha minus sine square alpha. This will be our second identity. All right. Within this also, we can have other representation because we know, let me see. If I take this one, which is the cos square alpha is the same as 1 minus sine square alpha from one of our identities we did from the Pythagoras theorem's identity. Units, they are using the unit circle. If you have that, it means I can replace all of this by this value, meaning I should be having 1 minus sine square alpha minus sine square alpha. This is equals to 1. This is the same as this. So minus 2 sine square what? Alpha. This could also be, so I say 2, this is 2a if possible, and these are 2b. Because the 2 is talking about the double angle for cos. Now, if I can also say that the sine square alpha is the same as 1 minus the cos square what? Alpha. Then that means the same double angle will now become, where am I? I should be having the cos square alpha minus into bracket 1 minus cos square what? Alpha. You see, this is replacing sine square alpha. When you open this bracket, negative will be here, positive will be here. So two of them will come together to give us, I think this will be 2 of the cos square alpha minus 1. And that also gives us our 2c. I think those are the 3 alternative form that we can have. You can have it in this form, cos square alpha minus sine square alpha. If the information is available, you go ahead. Or you go, if the information available is only about sine, you don't have a cos value, only sine value, then you can go along with this. Then if the question also gives you a cos value only, without the sine value, and you ask to find a double of the cos, you can go with this. Very perfect for that. So these are the first 2. Where is it? 1, 2. We need to do for this also. We need to clean this side so that we can get hold of that. So for the tan, we know the tan alpha plus beta is given by the first angle is alpha, the second angle is beta, 1 minus the product of the 2 angles. So in this case, we beta equals to alpha. If we let, I think that would have been the best way instead of saying but. Okay, let's go. So this become tan alpha plus tan alpha, right? Divided by 1 minus tan alpha, tan what? Alpha by representation. I guess that to be clear. And if that is true, I know 2 of the tan alpha adding give me 2 tan alpha divided by 1 minus tan alpha times tan alpha tan square what? Alpha. So we can say that, okay, therefore the tan 2 alpha become 2 tan alpha 1 minus tan square alpha. So this will give us the third identity. So we have gotten the 3 identities that we have for double angle identities. So the tan compound angle can be used, the sine compound angles, and the sine was the cos compound angle can be used to derive the double angle. The video is getting long, so we take examples in the subsequent episode, which will be episode number 38. Come back for more as we keep learning together. Bye-bye.